This is a re-recording of Monday's lecture, where the live stream audio was not captured correctly in the recording. So in Monday's lecture, we were looking at an old assignment. So this was an assignment from last fall. The assignment was, in the assignment, we gave the students some classes that implemented the game called Boggle. So Boggle is a word game played with 16 dice. Each dice is labeled with letters on their faces. Most of the dice have one letter per face, but there's one die that has the face labeled Q and U. So this is a word game. So the idea is you're supposed to form words by joining adjacent dice together. In the English language, most words that start with Q are followed by U. So if you're trying to form words by joining adjacent dice and you roll a Q without a U, then you probably won't be able to use that. You probably won't be able to use the letter Q to make any words. So one of the dice has the letters QU on one of the faces. To play the game Boggle, you put the dice in this contraption here and you shake it. And that randomly shuffles the dice. You then put the contraption down on a table, and the dice fall into a 4x4 grid pattern. Like this. So the idea in the game is to form words by joining adjacent dice together. You can see here the word questions is formed using that pattern. In this particular example, you can see other examples of words that you can form. So you can form the word, let's see, I guess ease. So E-A-S-E. Apparently you can do east. So E-A-S-T. And there's many other words that you can form as well. So normally you play with a 3-minute timer and you keep score. The scoring system scores words that are longer. It assigns higher scores to those words. And normally you play against one or more other players. Here's an example of the longest word that you can form in the game Boggle. So it's the word having 17 letters and consequentially. Of course, this probably would never happen in an actual game. To form this pattern, I placed the dice manually. Right? By chance, this would probably never happen. Okay, so there's lots of examples of this of the game Boggle, or games similar to Boggle. Right? Boggle is still very the physical game Boggle is still very common. So it's one of the best-selling board games still. There's lots of electronic versions. So, for example, the app called Ruzzle was for a time the #1 overall downloaded iPhone app in 2013. So it's still a very popular game. You can actually play this game. If you complete the assignment, you can actually play a version of this game. Right, so I'll just show you that quickly. So here it is running right now. To roll the dice, you can just press the re-roll button. To form words, you just click on the words in the grid. Right? So each letter here is actually represented as a button. And so we can go ahead and make some words. So for example, coin. Right? And then you submit the word with the submit button. If the word appears, if the word's a valid word, so if it appears in the English language dictionary, it shows up in the list of correct words. Now this version of Boggle also suggests words that are similar to the word that was just submitted. So a similar word is a word that starts with the same letter as the submitted word. It has the same number of letters as the submitted word, and it differs from the submitted word by exactly one letter. Right? So corn differs from coin in the third letter. Right? So the idea here is that if you're playing with a child who's just learning to spell, you could suggest some words to them that they might be able to form or that they can search for on the grid. Right? So if they form coin by doing that, maybe they can form corn or a similar word by changing one of the letters. Right? You're not allowed to enter 2-letter words in the game. So if you try to submit high, that'll show up as an incorrect word. right? And if you try to make up a nonsense word, so DNLT, right, that'll also show up in the list of incorrect words. Okay. So if you're going to implement this game Boggle in Java, you need a few things. Right. So first of all, you need that user interface that I just showed you. But that's beyond the scope of what we can do so far in this course. So we're not going to worry about the user interface, right? It was provided to students in the assignment, right? But what you do need is you need some way to represent the dice, right? So you need some way to represent the 16 dice in the game. You need a way to randomly shuffle the dice, right? So I need some way to simulate the shaking of the container of the dice so that you roll the dice randomly. You need some way to determine if a word entered by the player is correct according to the rules of the game. Right. So in other words, you need some sort of dictionary that contains the list of valid Boggle words. And it would be nice if, for younger players, you could suggest words that are similar to ones that they've already used. Right. And so that's going to affect how we implement our dictionary. Okay. So we need a way to represent the dice. So let's go and look at the implementation of that class. Incidentally, so Lab 5 for this week, if you download the Lab 5 project, you'll get the Boggle classes. So if you're looking for the classes to work with them on your own, you can just download the Lab 5 Eclipse project. All right, so the Boggle die class. Up here it says that it's a class that represents a 6-sided die where the faces or the sides are decorated with a string. Right. So whenever you go to implement a class, you need to decide what fields are needed to implement the class. Right. So here the question is what fields do I need so that I can represent a die? Right. Now you have to ask yourself, well, what exactly is a die? What exactly can a die do? Right. So you can roll a die. Right. When you roll a die, it changes to a random face. Right. So there's a random face that points upwards. You want to be able to ask the die what is the current face. Right. So if you roll the die and it's and the letter H is up, right, then you want to be able to ask the die, so what letter is up, and the die will tell you it's the letter H. Right? It shouldn't change. If you ask the die what is the current face, right, the current face should not change. And what else would you want to do with a die? I guess you have to be able to construct a die. So you need to be able to initialize one. So you need some way to store the faces of the die. Right. So with that in mind, right, let's implement the die class. So first of all, I guess we should start by deciding how are we going to represent or store the faces of the die. Right. Well, there's 6 sides on the die, so we need to store 6 things. Right. So 6 strings in this case. You probably don't want to make 6 separate fields. Right. So you don't want like a face 1, a face 2, a face 3, a face 4, a face 5, and a face 6. Right. Because that's going to be awkward when I go to roll the die, right? So if I roll the die to face 1, I'm going to need a big if statement that says, well, all right, if the side is 1, then return face 1, right? Else if the side is 2, then return face 2, right? So instead, I probably want some sort of collection, right? So an array or a list, those both make sense, right? A set doesn't make sense because the faces of the die can contain duplicated letters. Right, so here's an example of a die that has the letters A, E, and G, and N. Right, so the A and E are duplicated, which kind of rules out the set because a set only stores unique items. You could use a map, right? So you can use a map where the key 1 maps to the string for face 1, right, and the key 2 maps to the face for face 2, and the key 3 maps to the face for face 3. And so on and so forth, right? So that's a possible way to implement this class as well. I'm just going to use a list, right? So I'm going to use a list of string, and we'll call that the faces. We should make it private because our fields should be default should be private by default. When you use list for the first time, you have to import the list class, so I'm going to do that. Okay, so there's my list of faces, right? So those are the 6 faces of the die. I need a field to represent the face that is currently up, right? So the current face of the die. Now the faces are strings, so I could use a string to represent the current face, right? I have a list here, right, which stores the faces of the die. So I could also use an integer, right? So I could use the index of the current face, right? Or the current face would be an index, and the index would point to the current face, right? Either one of those is possible. I'll use a string today. So let's do string, and we'll call that current, right? So that's the current face. And now I need some way to roll the die, right? So I need some way to randomly roll the die to a face. Now again, I have a list of faces, so I can get the faces using an integer index. So if I can generate a random integer value between 0 and 5, that would let me pick a random face, which would let me simulate rolling the die. Right. So that suggests that I need a random number generator, which I'll call RNG. Okay, now remember the random class has a method called nextInt that will return an int between 0 and a specified number. So we're going to use that to randomly pick a face of the die. All right, so we want to move along. So on our constructor, so it looks like our constructor takes in a string of, takes in an array of faces. This comment is wrong. Right. We want to throw an exception if the number of elements in this array is not 6, right? Because there's 6 faces of the die, right? So to initialize the faces of the die, it makes sense that I need an array of length 6. We check if faces length is not 6. Then we throw one of these. And you can give a message if you like when you make the exception object. So I'm just going to say number of faces must be 6. So there's our input validation. Now, because you have an array of faces, it's possible that the elements of the array are null. Right. So for example, faces square bracket 2 might be null, for example, which you also don't want in this situation, right? You don't want to have a null face on the die. So you probably should check if each face of the die is not, to make sure that each face of the die is not null, right? So I'm going to put a comment here. I'm not going to actually do it today. I should probably check. Right, but you can do that with a simple loop. All right, now that I've validated the array, I want to initialize the fields of my object, right? So remember, that's the role of every constructor. So the role of every constructor is to initialize the fields of the object. So I have to make a list of faces, I have to set the current face, and I have to make a random number generator. So let's do that. So let's make the random number generator, so I can just use new random. Right, I have to make my list of faces. So this faces is a new array list. All right. And then I have to set the current face. Well, actually, I have to populate this list with the faces that are in the array. Right, so I need a little loop. So for each string face in faces, I'm just going to add that to my list. All right, so now I have a list of length 6. As long as the faces are all not null, I'll have 6 valid faces for my die. And now I need to pick the current face, right? So here you could do any one of a number of things, right? So you could simply set the current face to be equal to the first face of the die. Right? So I can do something like that. Whoops. Like that. Right? If you wanted to, you could randomly roll the die, right? Which you could do by calling the roll method that's further down in the class, right? Or you could pick a different face to be the current face, right? So you could arbitrarily choose face number 2, for example, to be this to be the current face, right? And that would be fine. So the contract for the method, for the constructor, sorry, doesn't actually say what the current face is, right? The contract simply says the current value of the die is unspecified, right? But calling get value immediately after constructing the die could return any face that belongs to the die, right? Is it actually called get value? Current face. So that comment is wrong too. Okay, so the constructor is done. Now we have a copy constructor. Now remember, the job of every copy constructor is to initialize the state of a new die by copying the state of the other die. Right? So this means that I want to copy the other die's list, right? And I want to copy the other die's current face, right? Whether or not you want to copy the other die's random number generator is an interesting question. So if you copy the die's other random number generator, then the sequence of rolls will be identical for both dice, right? Which you probably don't want for a die, because it's each die is supposed to generate a random sequence of rolls, right? So in this case, you probably don't want to copy the random number generator, but you do want to copy the list, and you do want to copy the current face. Right, now the list is the list of faces is an object, right? So I need to make a new list for this in this constructor, right? Because this is the constructor for a new object, right? The constructor will be called when you make a new object, right? Every object should have its own fields. So I need to make a list, a new array list for this die, right? Now, if I want to copy the other die's list of faces, I can simply write other faces inside the constructor argument list. Right. So when you pass a collection to a constructor of array list, then the constructor will copy each element of that collection and store it in this collection. Right. So so I don't have to write a loop here myself. I have to copy the current face. Right? So that's equal to the other die's current face. Right. Now in this example, I don't have to write new string here, although you could. Right. So here I made a new list. Right. But here I did not write new string. Right. So the reason for doing this is because strings in Java are immutable. Right. Once you make a string, you can't change the state of the string. Right. So what that means is I don't have to make new copies of a string every time I want to use a particular string. Right. Because the state of that string object can never change anyway. Right. To put it in other terms, that means you can share string objects freely and not worry that those objects will ever change. Right? So if you're working with immutable objects, it's often the case that you don't have to make a new copy of the immutable object every time you want to use one of those objects as a field of a class. Right? Array list is not immutable. Right? I can add elements to a list. I can remove elements from a list. Right? So if you want the two dice to have independent array lists, then you need to make a new array list here. Right? So if you have an immutable object, probably never have to make copies of the immutable object. If you have an object that is mutable, then you probably have to make your own copy of that object. Right? And finally, there's the random number generator, but I don't think we should copy the random number generator in this case because I want the dice to behave independently of one another. Okay, now what about roll? So rolling the die should set the current face of the die to a random face of the die. Right? So I need to pick one of the 6 faces of this die at random. Right? I have a list, so that means I can use an index to pick one of the random faces. And I have a random number generator, so I can generate a random int. Right? So int, we'll call it, let's call it an index. Is this RNG? So there's a method called nextInt, right? That has a bound, right? And it tells you that it will return a random number between 0 and the bound, but it doesn't include the bound, right? So if I do nextInt with a bound of 6, right, that will give me back a random number 0, 1, 2, 3, 4, or 5, right? Which is the correct index, which is a correct index for my list of faces. Right, so that picks one of the faces at random, and I simply set this current to this face's get the index. Right, well, that was easy. Oh, and then I have to return the current face, so I can return this current. Okay, not too bad. Now, how about the current face? So that returns a string corresponding to the current face. Well, this dot current is the field that stores the current face of the die. So I can simply return that. All right, now hash code. So I'll come back to hash code in a minute. I'm going to do equals first. All right, now when you implement equals, you have to decide what does it mean for 2 objects to be equal. So in this case here, there's already a contract for the equals method. Right? So the contract here says that 2 dice are equal if, well, if obj is not null, right? If obj is a Boggle die reference, and if the current face of this die and the other die are equal, right? Notice that 2 dice can be equal if they have at least one face label in common. That is, both dice do not need to have identical labeling of the faces. Right? I guess there should be a closing bracket here. Right? So you can have 2 dice that are equal, even if they have different lists of faces. Right? As long as their current face is the same, they're considered equals by this version of equals. Now, if you were designing this class on your own, you might choose that 2 dice are equal only if they have the exact same faces and the current face are the same. Right? That would be a perfectly legitimate version of equals. But here it says that we're only going to compare the faces, the current face of the dice. Okay, so for equals, you always follow the recipe that I showed you in the 2 lectures. Right? Step 1, you check if obj is the same object as this object. So if this equals obj, right? Are the 2 dice the same object? If so, I have to return true. Okay. The next step, I have to, if I use get class, I have to check for if obj is null. Right? If I use instance of, then I don't have to check if obj is null because instance of will do that for me. So let's use instance of. Right? So if not, obj instance of Boggle die. Right? So that just says if obj is not a Boggle die reference, right? So if it's not a Boggle die, they can't be equal. So that's going to be returned false. Right? Again, instance of, if obj is null, the null instance of Boggle die is also false. Right? So this will return false. So I don't have to explicitly check if obj is null. If you're using get class, you do have to check if obj is null. Okay, so if I reach this point in equals, I know that obj is a Boggle die object. So now I want to compare the current face of obj with the current face of this die. Now the problem is, right, the compiler thinks that obj is a big O object, right? It doesn't yet know that obj is a Boggle die, right? So I have to convince the compiler that obj is in fact a Boggle die, right? And you do that with a cast, like that. And now I can use the name other to access the current face of that die. Right. So I want to check if the current faces are equal, and if they are, return true. So I can simply return this current equals other current, and that completes equals. All right. Now what about hashcode? Okay, so the design of equals in this class is intentional because it's trying to catch errors that you might make when you're implementing hashcode. So remember that the contract for hashcode says if two objects are equal, their hashcodes must be equal. Right, and I also told you that to implement hashcode, you should just use the hash method in objects. Right? And furthermore, I also told you that when you compute a hashcode, you normally use all of the fields of the object to compute the hashcode. Right? So if you blindly or naively simply implemented hashcode like as follows, so return objects.hash, this faces, this current, and this RNG, right? You would have an incorrect version of hashcode. Right? Now, you might ask yourself, why am I going to have an incorrect version of hashcode? Right? Because the hashcode's computed using the list of faces and the random number generator. Right? But two objects are equal if their current faces are equal. Right? So in other words, equals only uses the field this.current to compute equality. Right? What that means is that hash must also only use the field this.current to compute the hash code. Right? Because if you compute the hash code with the list and with the random number generator, right? Two dice can have different lists and different random number generators, right? But still be equal because their current faces are equal. Right? So if you use all three fields, you'll end up with two different hash codes for the two objects, which is not allowed. Right? So when implementing hashcode here, you have to be careful to only use the fields that equals uses when computing the hashcode. Right? And now you've got a correct version of hashcode. We have a correct version of equals. And now we have toString. Okay, so to generate the string representation of a die, it's just the faces of the die. Now this implementation of toString is a bit odd because it doesn't include the current face of the die in the return string. So that's a bit weird, but that's the way that I wrote the contract, so we'll go with that. Now notice that the string, has this representation. Okay, so we want to make the string, the return string should have the faces of the die separated by a comma and a space. So this turns out to be a very common task where you take some sort of collection and output a string that contains the elements of the collection. Right? You can do it with a loop, but you have to be careful when you write the loop because the number of separators, right, comma and space, is different than the number of elements. Right? So the common thing that you see is that someone writes a loop, and each time through the loop, they print out an element followed by comma and space. Right? But what that ends up doing is when you print the last element, you end up with a comma and space after the last element, which shouldn't be there. Right? So one way to handle the problem is to start with the string that just includes the first element, right? And then write a loop that outputs the comma and space and the next element every time in the loop. Right? So in other words, you write a string like this. So this faces get 0. So that's the first face of the die, right? So in other words, I'm going to get the C, right? And now you write a loop to get the second, third, fourth fifth, and sixth element, right? So because I'm starting at the second element of the list, my loop index will start at 1. Size, I plus. And then so I'm going to add the separator followed by the next or the IP face of the die. And then return the result. Right, so that's one way to do it. If you know that the collection that you're iterating over is never empty, this is fine. Right? If the collection that you're iterating over can be empty, you can't always start with that. Right? So if your collection might be empty, you can't get the first element of the list automatically. Right? You actually need to check, is the collection empty? And if it is, then you want to return a string that corresponds to an empty collection. Okay, now this sort of thing is actually fairly common to do. So there's actually a class that does this for you. So I'll show you that. I pointed it out in the lecture, but I didn't actually show you how to do it. So the class is called string joiner. Right, so it's in Java util. Right, string joiner is used to construct a sequence of characters separated by a delimiter, and optionally starting with a prefix and ending with a suffix. Right, so it's not hard to use this class. So if you wanted to use this class to do this, you would do string joiner j is new string joiner. Okay, let's look at that constructor again to see what I should pass in. All right, so we've got two versions of the constructor. Right, so one takes a delimiter, so that's the separator. Right, another one takes a delimiter, a prefix, and a suffix. So the prefix is the thing in front of the return string, and the suffix is the thing at the back of the return string. Right, so if you were generating the string for a list, the prefix would be the opening square bracket, and the suffix would be the closing square bracket. Right, here there's no delimiters, so I'm just going to pass in the separator. Right, I need to import this class. There we go. Right, and now you just write a little loop. So for each string, or I guess I should call it face in this faces. Right, you just call append, I think, or add. What is it? Add? Yeah, add the face. Right, and then you can return the joiner to string. Right, so that's how you would write the method using string joiner. I'm going to comment it out. Oop, there we go. And I guess I'll move this back up to here. Right, so if you want to write your loop manually, you can do it like this. Right, if you want to use the string joiner class, then it's written like that. And that's it for the Boggle die class. So there's a little, there's not a tester here. I'm just going to copy out the tester from the lab, this week's lab, so that we can run the tester to see if I got everything right. Here we go. So let's run the tester, see how we did. Oh, we did pretty good, it looks like. So there we go. Looks like we've passed all of our tests, which is nice. So that's the Boggle die class. There aren't too many variations on how you would actually implement the class. You could use an array here, right? And the implementation would be largely the same. You could use a map here, right? So the map, you'd use the keys 1, 2, 3, 4, 5, 6, right? And they would map to the faces, the strings for the faces 1, 2, 3, 4, 5, and 6. Or you could use the keys 0, 1, 2, 3, 4, 5, right? And they map to the faces 0, 1. They map to the 6 faces of the die, right? But if you ever find yourself using a map like that, then that's effectively the same as a list, right? So you should probably just use a list because the list is going to be a lot faster and it's going to use a lot less memory. So in this case, I think a list or an array makes the most sense. Okay, well, let's look at the Boggle die class now. Sorry, the Boggle dictionary class. All right, so you know from assignment 2 that there are a few different ways that you can implement a simple dictionary, right? You can use a sorted array. You could use a tree set, right? Depending on what you use the dictionary for, you could use a hash set, but that would be a bit of an unusual dictionary if you used a hash set. That would be an appropriate dictionary if the only questions you needed to ask are, is a word in the dictionary? Right? As soon as you want to do any kind of range-based search, so give me all the words that start with a hash set's no longer appropriate because you have to iterate over every word in the dictionary. So here, remember that we want to be able to form this list of suggested words, right? So, so for example, let's try to find another word in here. I guess dent is in here. Oh, I guess dent's not in the dictionary. All right, how about end? It's a small dictionary that I'm using for this class, so it's not unusual that there's some missing words. So here, I want to find all the words that are similar to end, right? So I want to find all the words that start with E in this case, right? So I want to pick some sort of field here to hold the words of the dictionary where I can do these range-based searches, right? You can use either a sorted list or a sorted set in this case. You could use a sorted map again, but that doesn't make sense either because there's no mapping here. So let's use a sorted set. So private tree set. So these will be my words in the dictionary. Import tree set. All right. Now the way the dictionary works is it reads that file right there, right? So the method read dictionary reads the dictionary file, right? The dictionary file just contains one word per line. Notice that this is a very strange dictionary, right? It has words in it that most people would probably not consider to be English words. So it's not the official Boggle dictionary or the official Scrabble dictionary. Right? So all this method does is it loops over that file, reads it one line at a time. Every time it reads in one word, it calls the method add, which is in this class. Right? So it adds the word to the dictionary. Okay, so there's my field. Here's my constructor, right? What does the constructor do? It initializes the state of all the fields. So this word equals new tree set, right? Now, the read dictionary method will add the words to the tree set. So all I need to do to get this dictionary up and running is to implement add. Now, notice there's a contract here that's missing. If I'm lucky, I can find the contract. Okay, so the add method for the dictionary class is supposed to, I'm just going to copy the documentation out from the lab. Okay, so add should do this. For the assignment, the students had to fill in the Java doc here, so that's why it's missing from here. Okay, so the add method is supposed to behave similarly to the add method from assignment 2. You add a word to the dictionary if it's not already in the dictionary and return true. Otherwise, if the word's already in the dictionary, you don't add it again and you return false. Right? Now, set has a method called add already. And it returns exactly the value that we need. So I can just do return this word, add the word. Right, so that's fine for that. Now, what about the size? So the size is the number of words in the dictionary, right? But that's just the same as the number of words in the set. So I can just return this words.size, right? Okay, what about contains? So contains should return true if the word's in the dictionary. right? And false otherwise. Oh, sorry, wrong one. And again, tree set or all the sets have a method called contains. So I can simply return this this words contains the word. Right. The Hamming distance. Okay, so the Hamming distance is the distance between two strings of equal length. Right. The distance is defined to be the number of characters that are different between the two strings. Right. So there's your documentation for the Hamming distance. Okay, so the contract here doesn't say anything about throwing an exception. It should throw an exception if the two strings are different lengths. But let's just assume that they have the same length. So I'm not going to check if they have different lengths. So it's the number of characters that are different. So I need to count the number of characters that are different in the two strings. So let's start with that, right? So I'm just going to loop over both strings and compare the strings character by character. So I will be my index to loop over the strings. So if s car at I. So if it's not equal to t car at I, right, you're going to add 1 to the difference. And then you're going to return the difference. Okay, that was pretty easy. Now, what about words similar to? Okay, so for words similar to, let me first grab the contract for the method. Okay, so for words similar to, I want all the words that are similar to that word, right? So our definition of similarity is the word starts with the same letter. The similar words start with the same letter as this word, and they have the same length, and they differ by 1 in their Hamming distance, right? So what I need to do here is I need to ask the set. Well, I can do this one of 2 ways. I can try to ask the set for all words of the same length as that, right? But there's no way for a tree set to give me that information, right? I'd have to loop over all the elements of the set. The alternative is to ask the set for all words that begin with the same character as this word, and that I can do, right? So car C is equal to word car at 0, right? So what I want to do is I want to call this method, sorted sets. So this is right. So I want the set of words that start with the letter C, right? And the way I want to do this is I want to call the I want to call the sorted set method subset. Where is it? Subset. This one. Right. So the subset method returns a view of the portion of this set whose elements range from up to, but not including 2. So remember, this is a sorted set. So I can ask for all the words that start with the letter A, right? And go up to words that start with the letter B, for example. And that will give me all the words that start with an A. Right? So I want something called from, and I want something called to. Right? So from is going to be, I know this is a set of string, so from is going to be a string. Right? So string from equals. So I want all words starting with the letter C. So I want from to be equal to C. Right? But I can't write that because C is a car. Right? So I have to turn C into a string. The easiest way to do that is to append the empty string to the front of C. Right? So now Java will do string concatenation here. right? And return the string that's made up of the character C. String 2, okay, so I want to get all of the words up to but not including the word that starts with the next letter in the alphabet, right? The next letter after C, right? So the next letter after C is the letter C plus 1, right? Because remember, cars in Java are just numbers, right? If I write C plus 1, though, that turns that into an int, right? Because 1's an int. So if I do C plus 1, that makes an int. So I have to cast it back to car, right? Okay, now I'm in the same situation, right? That's a car, so I need to convince the compiler that this is in fact a string. So I write the empty string plus that car, right? And now I've got my from and to, so I can ask for that subset. Right, so that's words starting with. That's all of the words that start with the same letter as the string word. Right, now I just have to loop over those words. Right, so for each string, I guess for each string S in words starting with, I want to check, does it have the same number of characters as that? Right, is it the same length? So if S length is equal to the word length, right? So if they have the same length, I can compare their Hamming distances, right? So if, now, I think that's static, right? Yeah, it's static. So if the Hamming distance between S and word is 1, right? I want to add S to the set of, to the returned set. Right, so I'm going to call my return set result, add S. All right, so up here somewhere, I need to define what result is. Result is supposed to be one of these. So I need to make a new sorted set. Now, sorted set's an interface, so you can't make a sorted set. Instead, you have to make an object that implements the sorted set interface, and that happens to be tree set. Right, and now I'm done. Right, I just return the result, and we're all done. I'm going to copy out the main method from the other class, from our lab class. I'm going to get rid of this line here for a second. Okay, so this is going to make a dictionary. It's going to check for all the words that are similar to yard. So what happens when we run that? I get, I get a long list of words. Which dictionary, right? Oh no, I'm using the right dictionary. Okay. All right, so apparently there's a lot of similar words to yard. Sorry, that surprised me. I thought we were using a smaller dictionary in this example. I am using oh yeah, I'm reading the dictionary. Okay, so I thought it was a smaller dictionary. What about T? Right, apparently there's quite a lot of them. Right, and what about something that there's not going to be a lot of? So zebra, there's probably no word similar to zebra. Right, apparently there's one. That surprises me, right? There's the word zabra. I didn't know that was a word. And so there's the simple implementation of the dictionary, right? Using a technique similar to what you did in assignment 2. Now, in the lab this week, I'm going to change the representation of the dictionary. So I'm not going to use a simple tree set. Now, the reason why I'm going to change it is because down here, when I'm searching for the words that are similar to another word, right, it's actually quite expensive. So to find the word similar to a word, I'm going to find all the words that start with the same letter as that word, right? But that set of words is a lot larger than, is probably a lot larger than the words that are actually similar to that word, right? Because I only want to look at the words that have that length, right? So it would be nice if I had a dictionary where the words were somehow sorted or kept by their length, right? Of course, I also want them to be sorted alphabetically, right? But I want some way to keep the words, to pull out the number of words with length 3, for example, or the number of words with length 4, for example, right? Currently, all that I can do in a somewhat efficient way is to pull out all of the words that start with a certain letter, right? To answer this question efficiently, I really want to do both, right? I want to get all the words that start with a certain letter and have the same length, right? So that's what I'm going to do in the lab this week. That completes this lecture.